You're almost there. You're on question 5 of our review using the free response questions from the 2013 AB Calculus AP exam. So here's an area volume question. You are given the intersection points since this is a no calculator question, and you know which is which because f of x is a parabola that opens up, so it must be this lower function, and g of x, this cosine curve. So remember that g of x is on top of f of x. So in part A, we're doing the integral, so we're adding up these Riemann rectangles as we move from 0 to 2. So the height of the Riemann rectangle is the distance between these 2 points. So it would simply be g of x minus f of x, top minus bottom. So our region R is all of these rectangles from 0 to 2, g of x minus f of x, and the thickness of each rectangle is our dx. And no calculator, so we have to do the hard work of integrating this. But I think we can handle it. So g of x is our 4 cosine, and I'm going to write this as a pi over 4x, and then minus our f of x, and I can integrate this one using the power rule. All right, so in the first part here, the trick is that there would be a chain rule of pi over 4. So to make that cancel out, we would have to use the reciprocal of 4 over pi. And cosine is the derivative of sine. So if you're not with me, check it out here. If I do the derivative of this term, will I get back to the integrand? So do you see what I mean about canceling out the chain rule on the pi over 4? So it's a u/du substitution problem, but we're not writing out those steps anymore. And here's our power rule, so we're going to raise this. Oh, I think I jumped the gun there. That should be a x squared. Now I raise it to an x cubed and divide by that new power. Here I raise the power to a 2, and I divide by it, and here we'll have a 4x, and we still have this negative sign to distribute. All right, and then we're going to have to evaluate all of this from 0 to 2. All right, well, we like this fundamental theorem because when we put 0 in, all of these x terms drop out, and sine of 0 is also 0. So we only need to evaluate this when x is equal to 2. So we'll have a 16 over pi sine of, when we put 2 in here for x, we'll have pi over 2. And of course the sine of pi over 2 is 1. And here we're putting 2 in, so we'll have a 2/3 of 8, or a 16/3 if you prefer. And here we'll have a negative 3 times 4 and a 4 times 2. So this is 16/3 is 5 1/3. So I have a positive 13 1/3 minus a 12. So I think I can do that. Arithmetic. 1 1/3 is what we're going to end up there. And again, sine of pi over 2 is 1. So this is going to give us a 16 over pi. And that's the best answer we can come up with. And now let's go see what B is asking us to do. Write but do not evaluate an integral expression that gives the volume if this region R is rotated about the line y equals 4. All right, again, you do not have to make a diagram unless directed to do so, but let me just remind you here, this was our line 4, y equals 4. It's a pretty bad drawing of those graphs, but we'll make do, I think. And so we're going to get a washer method here. So our outer radius, the outer radius goes down to the bottom function, remember, was f of x. This point here is x comma f of x. So our outer radius goes from 4 down to f of x. And our inner radius, if I change colors here, our inner radius goes from 4 down to g of x. So our volume, remember that this point was at 2, this point was at 0, 4. So all we need to do is add up these washers as we move across from 0 to 2. Sorry for the diagram that's not very pretty there. So we've got our pi r outer squared minus pi r inner squared, large circle minus small circle for our washers. So our outer radius is 4 minus f of x. Oops, and I didn't leave nearly enough space there. And our inner radius is 4 minus g of x, quantity squared. And the thickness of each washer is our dx. And that's all we needed to do was to set that one up. And let's check out C. Region R is the base of a solid. For this solid, each cross-section perpendicular to the x-axis. So as soon as we see that our Riemann rectangle crosses the x-axis, we know the thickness of the rectangle is a dx. We are having perpendicular cross-sections are squares. Easiest one, if we can find the length of the base, the height is the same, we just square it. And we have to write an expression for the volume, but do not evaluate. Again, you do not have to make a diagram. And after seeing my awful diagram last time, you might wonder why I think I'm helping you. But let's see if I can do better. So here's that parabola that went to 2 on the x-axis and 4 on the y. And then we had that cosine wave. So this was our function g and this was our function f. And now we're taking cross sections. So I'm going to make a rectangle from one side to the other, perpendicular to the x-axis. So that's telling you that your thickness of that rectangle is a dx. And then on top of that, we are building squares. So remember what we knew. This point was our x comma g of x. And this point was on the f curve. So the side of our square, the side of the square there was the distance from the y-coordinates, g of x minus f of x. And of course the height would be the same thing. So now all we have to do here is say, well, how many of these squares are we adding up? We are going from 0 over 2. This intersection point was at 2. So our volume is just a bunch of squares. The integral accumulates all of them. G of x minus f of x, quantity squared. And you could leave your answer in that form. You could substitute in the values of those functions if you wanted to, but they have names, so that would be acceptable. I think we're all set.